logical. Next thing to ask for, and it's, let us start with
we're doing roads today. Roads, I tell you. Roads. All the roads. Okay.
breaking down the initial concept. It's actually like stupidly simple. What we need to do, let's say we have some curves with arbitrary topology, which means there is no particular account for intersection points, so we don't know nothing about this at the moment, and we need to flatten it. Usually it's easier to manage this. We probably want to store some kind of rest position, but it's different discussion. And then we just need to find these points, these intersection points. Luckily, there is a particular node that will give us
Turn this into
this
proper
information.
roads.
So we get
Big
our
roads.
points. Now we know not only the points, but also we know which primitives has its point as an intersection. And also we know the value from 0 to 1 on each of these curves. So in this particular example, it could be something like 0, 35, or any other float value from 0 to 1. So based on this information, we will be able to split each line based on the intersection points. And then we will split it once more. So we need each segment to go either outwards or inwards. This needed for us to be able to extract the curves that would be used later as a source for crossroads geometry. So let's go to Houdini. And this is really, really simple concept overall. And we will start with looking at the setup. So I have draw curve set to zxplane just to get maximum arbitrary curves for testing. Then I flatten the scale in axis y. Then I get rid of any unnecessary details. And then I resample testing. Then I flatten the scale in axis y. Then I get rid of any unnecessary details. And then I resampled this once more to get additional smoothness.
I don't care that much about the points right now, but we'll come back to this. I just want to try and get it to a point where um
Why? Then to that explain just to get maximum details and then curves for testing. Then I flatten the scale in axis y. Then I get rid of any unnecessary details.
straight edge. Okay. Yeah, and then this is the subdivide.
And then I
curve.
resampled this once more to get additional smoothness in these curves. That's basically it. So for now, as you can see, we have just separate curves without any account of intersection points. Let's add intersection analysis node. It has given us some points which
This is kind of cool. It shows us where the intersections are, even if we don't have them. It's really cool. Oh, that looks so interesting. You see certain things darker and lighter than I do. Is that actually how you guys see it? No, okay. That's just that render.
corresponds to intersection points of our curves. And then we need to output two attributes, first of which would be primitive number. And as you can see, it's not just an integer value, it's array of integers. So it will give us every primitive that has this point as an intersection. And same thing with prim.
Oh, interesting. Huh. He has one specific one. And I think I might actually recreate his. He's called it Wrangle, and I kind of like it. Well, at least part of it. Uh, there we go. There. Now we can take a look at this. We've got the different primitives here. Here we go. We've got the points, we've got the source prim, and I think this revolves around where they overlap. So in this case, 0 is there's an intersection at 0 and 2. I kind of wonder if this would handle triples. Like sorry, 5 incoming pieces. But let's take a look at these numbers here and see if I'm right. There's 0. There's 1. Oh, right, because we don't have the pyramid. No, whatever.
UVW. Basically, this is all the same information that we can get from scatter node, for example, or from ray node, and this will give us the parametric UV coordinates, and we only care about X component of this vector. And what I want to do, I want to iterate for each primitive in our initial geometry if there is any items with the same number as current primitive in the source prim array. Then once I know that, I can get the corresponding value from the second attribute, which is source prim UV. To do so, we will need to create attribute wrangle. We will set this attribute wrangle to primitives. So let's start with creating load array attribute. Let's call it coords, and it would be equal function array, which allows us to create arrays. And second step would be to iterate for each point in the second input, so points that we have generated. So as usual, less than endpoints from second input. And as usual, I++. Next, let's create a couple of variables. We probably will promote them upwards, but for now, just to not spend time, let's create them inside of loop. So first one would be source primitive, and we will get attribute source primitive from each of our points. So point, second input, attribute would be source prim, because we call it that way. And the point would be I, because I need to set initial I value to 0 here. Now it stopped complaining. Then we will create second.
Yeah, so this grabs from here, right? And we get the point for source prim. We get the data and then we stash it there. Okay.
Array. And just to recap, we simply have gotten this array attribute to array variable. That's it. And second one would be vector array variable. So vector, and let's call it source UV. And of course, we need to say that this is array using square brackets. And actually, we can just copy this expression here and change attribute name to source prim UV. Then let's store the number of element of this particular primitive in source prim array. So to do so, we will create variable called, let's say, prim id. So let's use function called find. This function will search in some array for a particular element and will return the number of this element in array, position of this element in array. So first argument would be an array. So in our case, it's source prim. We don't need to use square brackets once we have initialized this. So we can use it just a simple variable. So nothing special here. And the value that we try to find is primitive number, so current primitive number. And then we will write a simple condition in which if this value would be less than 0, which means that we haven't found anything, in this case, we will just skip to the next iteration. Just to not overcomplicate our code with additional curly braces or if blocks, we can just simply say this loop when to stop in that way. And then
Interesting.
we will append new value to the initial array. And the value that we will append would be some value from this array source UV. So it would be source UV. And the number of element from this array would be the prim ID that we have found. But we don't need whole vector. We need just x component from it. So we will type x. And let's look at what we have. Gotten. So as you can see, we have cohorts array, which consists
Oh, right, because it's going to the primitives.
of initial values 0 and 1 and the values that we have added to this array. Last step to do here is to sort this guy. So it would be like that. This particular attribute would be equal sort from the same attribute. So we're just saying that now you are a sorted version of yourself. And as you can see, everything sorted. So this is our first step. Now we care only about values inside of this particular primitive, so we can go on. Next, we will cut primitives. Basically, what we will do, we will create new primitives on each of these segments and we will get rid of initial.
I wonder if this is actually required. Because I think at this point we can just go do this. We've already defined it. Yeah. So I think when we do this, we'd probably do that because and then when we use it, we would use this. Yeah, okay, this does do what I thought it did.
Shell one, pretty simple. And just to save some time, we will reuse the function from previous session, and this function would be prim from array. I will just remind you what this custom function is capable of. Basically, it's
They want another one?
taken current primitive and and based on some array variables from 0 to 1, it will create new primitives using the initial primitive position. So we can control topology in the place of previous curve in our case. Next, let's store this attribute for simplicity to variable, and it would be float array coords, which would be equal this initial attribute with coordinates. And then we
This doesn't store anything.
need to iterate through each element of this array and create primitive inside of each iteration. So for integer I, as usual, equals 0, I less than length of this coords array, so number of elements in this array, but -1. And the reason why we use -1 in this case, because we will need to get next iteration from the current one. So you will see what I mean shortly. And then, as usual, I just create a body of function here. Let's start with creating a variable called iters, so number of iterations, number of new points in each primitive. For now, let's make it equal channel iters that we will create later. Then we need to store new values that we will get from current element and the next element. And let's actually define them before. So let's call first one float v0, and it would be equal the element from coords array number I. Next one, float v1, would be equal element from coords array, but the next element, which means I plus 1. In this float new list array, we will use resample linear. We also have used this one in previous session. And then we will create array from v0 and v1. And we will generate some amount of values using the iters variable. Okay, no errors so far. Then what we need to do, we need just to create the primitives. And for that, we will use primitive from array function that we created. And the first argument would be current primitive, so primnum, and second
Ugh. Oh my god, am I ever tired? I might not make it tonight. Oh, I'm sorry.
argument would be the new.
All right. So this is the resampled list.
List that we have created. Let's see what we get. Now we have a lot more primitives here, but
I'm not really seeing the primitives. 0, 1, 2, 3. whatever.
But let's get rid of previous ones. So remove prim from 0 input, from first input. We will remove current prim, and yes, we want to get rid of any points. For now, it seems like we don't have anything, but it's actually because of the fact that we need to increase our ethers. So now, as you can see, we have
Interesting.
separated segments. Let's use exploded view to confirm. And yeah, now, as you can see, we have split our segments, which is kind of counterintuitive because we actually created new ones. We haven't split anything. So next step is to have this central cut. Let's use carve node to just see what we have here. It actually can be achieved using
Interesting. Interesting.
the carve node, but I want to spend some time in this code just to illustrate some of the concepts. So let's actually create new list 0 instead of just a new list.
Oh, that's this explode view.
Because as you guessed it, we might have second one because we will need to create these primitives twice. First one would use the new list 0 and second one would use the new list one. For now, we will just duplicate the existing ones, but we need to tweak these values. And what I will do, I will just use v0 plus v1 as a second argument here. Don't forget to add parentheses here, and I will divide it by 2. And I will
Interesting.
duplicate this value, and I will use it instead of first argument in our second array. So now, as
Now this is kind of bad practice because he's calculating this twice. Here, what we want to do is float and create this as a temporary value. And then we can take this, and now this gets rid of our divide by 2, which really should probably be a multiply by 1.5. But we're going to do this. There we go.
and I will divide it by, I will just use v0 plus v1 as a second argument here. Don't forget to add parentheses here, and I will divide it by 2. And I will duplicate this value, and I will use it instead of first argument in our second array. So now, as you can see, we have splitted our segments. But for now, it's still not doing what we want. We need to reverse each second of them. And to do so, we will simply use a reverse function. So new list 1 would be equal its reversed version. So reverse from new list. 1. So it's kind of straightforward, and you don't have to rely on any tricks. It's just a simple, straightforward logic. You don't have to memorize any like sophisticated algorithms or something like this. You just act logical. Next thing to do is to get our intersection points, so these points basically, and place them into some kind of group. There are two ways of achieving that. Both will require us to type some expression and group expression. Note, we'll set it to points. And the first one is the most straightforward one. However, it won't work with any case. We'll have to use slightly different approach, but this one is also valid in some cases. From this menu, we will use point valence preset. So it will type for us some kind of expression, and we'll set this point valence points. And the first one is the most straightforward one. However, it won't work with any case. We'll have to use slightly different approach, but this one is also valid in some cases. It's the most straightforward one. However, it won't work with any case. We'll have
The group expression?
to use slightly different approach, but this one is also valid in some cases. From this menu, we will use point valence preset. So it will type for us some kind of expression, and we'll set this point valence to 2, for example. As you can see, for now, it's selecting not the points that we want. So to make it work properly, we will use fuse node, and this one
Mm. What if I do this and I come down here and I yeah, oh, this is not doing what he wants. Oh god. Alright, yeah, I am fucking exhausted. I know. 30-minute stream, I'm gonna call it. I'm just too tired for this. Alright, night everybody.